Thank you, everyone, for being here today. I would like to take you all to a journey to the tropical world. My name is Matheus Henrique, and I would like to go through the experience the forests they have been going through climate change. But how are they responding to climatic extremes? We already know when we look at this graph here in red, we see that most of the world already has been experiencing climatic extremes that are actually influenced by human causes. So climate change actually has affected extreme events around the world. So in red, it's exactly where scientific evidence has been showing that climatic extreme these events are happening already, and other places, for example, in blue, it's where science hasn't proved yet. So we can see that there's mounting evidence that actually it's happening. But how are plants, trees, and forests responding to these events? Well, I don't know, probably most of you have plants at your house, and you can see when you change to a different room, sometimes these plants, they also can change. They can respond differently in different ways. Sometimes we never know. Sometimes they just change the color of the leaves. Sometimes they can grow even more. Sometimes they grow less. Sometimes they can die. There's a bunch of physiological, anatomical change that can happen. And forests are exactly the same. But it's very complex because sometimes we're talking about thousands of plant species that respond in different ways. And how these forests, they're responding actually to these climatic events. I live in places like this, in the Amazon forest and Borneo and Kenya. I have spent years living in open huts like this one that jaguars pass by in the middle of the night. It's very exciting. And I also use lasers and scanners to map forests like this one. I go to the field, I carry them, and they can give me very nice videos like this, where I'm able to reconstruct a virtual reality forest that is three-dimensional, and it gives me like a lot of certainty about how forests are, the structure of these forests, and when I do it repeatedly over time, for example, I can do like on a monthly basis or on a yearly basis, it gives me like a better perspective about like the changes in the structure of these forests and how climate actually is influencing them. But how are these forests doing then? Are they okay? Well, of course, it varies a lot. There's a lot of evidence that is showing now that the Amazon forest, for example, is not doing very well. The mortality of trees has increased a lot in the past years, and that means a lot of carbon has been emitted from these forests. African forests, they seem to be doing much better. The reasons why, we are not completely sure. Southeast Asian forests, they respond also in different ways. When we look at these logged forests, this is a photo of one of the areas where I was. I spent 1 year during my PhD. We show that these forests actually, like these logged forests, they are doing a lot better. They're increasing in growth, and they are able to capture more carbon than old growth undisturbed forests. But that doesn't mean that we need to log forests to make it like, to be doing good for our planet. No, not necessarily. But what I would like to draw the attention here today is that there's one particular forest that is not doing it right, and they are called fragmented forests. When you've got like a continuous area with large forests, and you break them into pieces of fragments, these small areas, they tend to be to have like very high temperature, and that sometimes it creates more easy access for people to come in and explore and log more trees in these patches of forests. And these forests actually, they're not doing it right. So what that means is that not only deforestation is creating a pressure on these forests, but the remaining forests actually, they are suffering a lot from this, what we called fragmentation effect. So when I would like to invite you all to think more about it and talk more about it, about this fragmentation effect, that this actually is creating a lot of pressure on the species diversity we observe in the tropics, but also the role in biogeochemical cycles like carbon. So these forests, they are usually carbon sources because they are emitting more carbon to the atmosphere and just enhancing this carbon, this pressure on the planet in general. So what are the solutions to having less fragmented landscapes? I think this is like a very complex thing, but in the future, probably we need to talk a lot more about using, like valuing forest products, having like agroforestry, just not just like extensive agriculture with thousands of hectares of crops, but also having these very small farms where people, they try to imitate the natural life cycle. And of course, for example, when you look at the Amazonian forests, where acai berry has a revenue of $1 billion per year. That means actually, if we start looking at these products, we can maybe that's one of the solutions actually to having less deforestation and fragmented forests around the world. Thank you very much.
Thank you so much, Matheus. Super interesting and lovely visuals. Let's talk a bit about the fragmented forests. Let's go back to the fragmented forests, just because I know that you already explained a lot of things about them, but they are such a key concept here. Forests are not naturally fragmented, are they? How are they created? What are we as humans doing that actually makes them fragmented?
That's a very interesting question. When you have there are several factors actually, everything that can break forests into pieces, for example, agriculture expansion. When you go to the tropics, not just the tropics, around the world, actually fragmentation is a problem around the world, not just the tropics, but when you go there, it's very, you can see I'm Brazilian, so Amazonian forest is a place that I know a little bit better. So when you go there, you see vast areas with cattle pasture, and but also croplands, but also infrastructure like cities, roads. Roads actually they represent. There's a very nice study that's showing that the areas in the Amazon that are like 25 kilometers close to any road, it means those areas, they suffer from a lot of human pressure. You know, they create easier access for people to come and like exploit those forests around these roads. You know, it creates easy access for everyone. So there's a lot of things that we can think about. You know, agriculture expansion is something like that. Like when you have to create a new land, you just not deforest the area, but you also those areas around it suffers a lot from higher temperatures. And when there's one study that is coming out very soon that I'm my first author. It shows that trees in the Amazon, in areas that are above 35 degrees Celsius temperature, it tends to suffer a lot from these very high temperatures. And we have observed that in these fragmented forests, high temperatures are a lot more common.
Sounds pretty terrible. So when you actually have a farm, it's not just the farmland that suffers, but lots of land like not right next to it.
It is, and it's very interesting because sometimes the first 50 meters from the edges can suffer, but sometimes it can be 2 kilometers. And when you sum all these amounts of forests that are under pressure from these deforested areas, that means actually a lot. Only in the Amazon, the amount of forests suffering from fragmentation effects are the same size as Portugal, the country Portugal. So there's a huge amount of forest actually that is also indirectly emitting more carbon because of these fragmentation effects.
That's very worrying. Thank you for the great explanation about it. You actually showed an amazing animation in your talk. Could you tell us a bit about the kind of impact of being able to use such high quality tech nowadays in your work?
This is very nice, actually. For the past 30 years, we have developed a lot of laser scanners, and Finland actually has been one of the pioneers in the use of laser scanners in the world, actually. And this is one of the reasons why I'm here, because I would like to benefit from this technology that is being produced here in Finland. And the amount of information, the quality of the information with such fine details that you can retrieve from these laser scanners is so nice that you can have like a completely different perspective about forests. You know, like now, how we understand about the climatic effects on the structure of the forest by using these laser scanners is like unprecedented. It's in a very fine and large scale at the same time. NASA now has launched one satellite which is also called LiDAR, which is this equipment I'm using. But it's a space-borne LiDAR, so it's rotating around the world and continuously measuring the biophysical, like the structure of the world's forests every second. And we have this technology now, and we definitely have to try to understand how to use them.
Sounds incredibly interesting and kind of sci-fi. I would like to know something about how you actually got into studying this in the first place.
That's very interesting. I was 17 years old. I was raised in a rural area in Brazil, in one of the savanna-like places. It's called Cerrado. And the huge amount of species, plant species, animal species, mineral species around us was fascinating. So it was definitely something that inspired me. And when I feel a little bit down, I'm just like, think about it again, Matheus, how diverse the world is and so many things to understand out there.
That's a wonderful kind of way of thinking and mode, such a researcher's mindset. Thank you so much, Matheus. Let's have a warm round of applause for Matheus Nunes.
Kiitos.